Okay, so let's wrap up these handouts with handout 12E, and that's going to focus on our three neurotransmitters that I want to mention. Now, these are just going to be some examples. So I have this Venn diagram that's going to mention three of our neurotransmitters that are located in our brain. All right, so I want to talk about serotonin, epinephrine, and dopamine. Now, neurotransmitters are going to have different effects on our nervous system. So they do different things. They cause different areas of our brain to become active. They may inhibit other parts of our brain. And so when we release a neurotransmitter, it's going to have a profound effect on the brain. So let me give you an example here. Let's look at norepinephrine first. Norepinephrine, when we produce and release norepinephrine in the brain, it's going to have an effect. It's going to cause our energy levels to rise. It's going to affect our alertness. So the more norepinephrine you produce, the more alert you become, and the better you can concentrate. So hopefully, like right now, as you are watching these videos and you are studying, you are producing norepinephrine. You should have alertness. You should be able to concentrate. And your energy levels should be higher because you are secreting norepinephrine into the synapses of your brain neurons. All right. Now, contrast that to serotonin. Serotonin is going to help us with memory formation, and it's also going to play a role in controlling obsession and compulsion. So, serotonin is going to play a different role in our brain when we release that neurotransmitter. Then look at dopamine down here at the bottom. Dopamine, when we produce dopamine, it's going to help us with drive. So, dedication and drive to stuff, motivation. And then it's going to also initiate reward and pleasure. So when you are doing something you really enjoy, you are going to be releasing dopamine. And these neurotransmitters can also be addictive, and this can lead to addictions. Your brain craves dopamine, and that can be an issue. And some of these drugs, for example, cocaine, will artificially raise your dopamine levels, and so you crave that. It's pleasurable. Now, this is a Venn diagram, right? So when we release more than one of these neurotransmitters, we're going to have more effects. So for example, when we are releasing norepinephrine and serotonin, we're going to have these effects where we have energy, alertness, concentration, memory, control over obsession and compulsion, but it's also going to regulate our impulse, anxiety, irritability, mood, cognition. All right. So all of these behaviors are going to be controlled by norepinephrine and serotonin. Now look at norepinephrine and dopamine. So when we need to really concentrate, we are going to be secreting both dopamine and norepinephrine because it helps us with our attention. If we are secreting serotonin and dopamine, that's going to help us with things like aggression control, appetite, and our sex drive. So you can see how these are linked. I mean, just imagine, someone producing serotonin and dopamine, that can increase their sex drive. It increases their obsession, their compulsion, pleasure and reward. Oh my gosh, I just described, a stalker. There's a guy who's really interested in, a girl. He becomes obsessed with her. It's a sexual thing. It's an aggression thing. It's a pleasure and a reward. He's motivated. So this can be, I want to say it can be due to secretions of various neurotransmitters in the brain. These are controlling your brain. All right. Now, if we put all three of them together, it helps balance our mood and it balances our cognition. So these neurotransmitters and how they're released and the quantities and amounts that they're released in our brain can control these behaviors. One of the easiest ways to think of this is think of some disorder like ADHD. ADHD is a good example. If a child is suffering from ADHD, they may have a problem with one of these neurotransmitters. Now, I want to say may have because there's a lot of other factors. But just look at this. Let's say a person's having a hard time concentrating. So they're not concentrating. They're not staying alert. They have a short attention span. Their cognition, they're having trouble with cognition. This could be perhaps an underproduction in their brain of norepinephrine. Let's say someone is suffering from large bouts of depression. So they don't have pleasure, reward, they're not motivated, they don't have drive, they lose their sex drive, they may have no appetite or they may have, a large appetite. They may be very moody. That could be an imbalance of dopamine. And so you can see how these correlate to some of our behaviors. This is also why it's really hard to treat this kind of thing, because I'm just talking about 3 neurotransmitters here, but we've got dozens and dozens of neurotransmitters that can be affecting something like depression. Dopamine is one of these. It's one of the big pleasure neurotransmitters. But if, let's say, someone has ADHD, they may be put on several different medications to try and figure out what is the balance. Do we need to lower or raise norepinephrine? Do we need to lower or raise dopamine? So these different medications may influence the production of these neurotransmitters differently. And they have to play around with those. So one medication that may work really well for one person may not work for another because they have a different imbalance. All right. One other thing before I move on, I mentioned addiction. A lot of times with addiction, what it does is it increases our dopamine levels. And I mentioned cocaine is an example of that. What cocaine does is it boosts your dopamine levels. So that gives you that pleasure feeling, which you crave, and then you want more of that pleasurable feeling. So you want to release more dopamine. And so you take more cocaine to cause more dopamine and more pleasure. What's funny is they've done some studies and it turns out that your cell phones are doing the same thing. Your cell phones are artificially inflating your dopamine levels, and that's causing little pleasure. And so you crave that, so you do more and more on your phone. A good example of this would be social media. So anytime you post something on social media and you get a like or you get a response or you get, any kind of feedback, that feedback is releasing dopamine, which causes you to feel pleasure. You like that attention. So that those pleasure areas of your brain get stimulated with dopamine, you crave that, and you want more of that. And so then you are doing social media more and more and more. You're releasing more and more dopamine. The problem is your brain gets saturated with dopamine, and then to get the same effect, you need more dopamine. So then you're producing, or you're doing that addictive behavior more and more and more, because you need more and more and more dopamine to get that same pleasure response. And so that's why you get kind of desensitized to certain things, and you want more of it. So it works with cocaine. It works with cell phones. Kind of crazy. Not to harp too much on cell phones. I'm kind of anti-cell phone, especially in class. You got to keep your cell phones put away. It drives me crazy. But people are addicted to them because of that dopamine rush they get when they are on social media. It's funny, in my high school class, I've got a phone caddy, and I try and keep phones out of the class. So I will put the students' phones in the phone caddy, but above the phone caddy, I've got a technology addiction hotline phone number, and it's an actual real number where people that have addictions to their technology can call in and get help. So if you can't put your phone down for 45 minutes, I always suggest that they call the technology addiction hotline. Okay, so that's just kind of a funny, interesting little fact with neurotransmitters. So let's finish up the neurotransmitters here. So neurotransmitters, like I just mentioned with our Venn diagram, their effects can be modified. So we can synthesize more neurotransmitters to have more of an effect. We can inhibit the synthesis. We can block or enhance a neurotransmitter. We can remove a neurotransmitter or block the removal of a neurotransmitter. We can manipulate the receptor sites on the cells that are affected by the neurotransmitter. And so we can turn on and off these neurotransmitters. Now, there are neurotransmitters that help each other. They're agonists. So anything that's going to enhance a neurotransmitter and the effects of a neurotransmitter is called an agonist. Anything that blocks or inhibits neurotransmitters, they're called antagonists. So it says anything that blocks a neurotransmitter, things like monoamine oxidase or MAO inhibitors, they're going to be inhibiting different neurotransmitters. All right. So here are some examples of neurotransmitters. I'm not going to spend really any time on acetylcholine, but let's look at these. So there are some amino acid neurotransmitters. It says glutamate is released by nearly all of our excitatory neurons in the brain. So when we're awake, we have these excitatory neurons that are stimulated by this neurotransmitter glutamate, and that keeps us active. So it says it's inactivated by glutamate-specific transporters. These neurotransmitters are secreted when we want to turn our brain off. For example, when we want to go to sleep. So it says GABA, gamma-aminobutyric acid, is an inhibitory neurotransmitter that is going to affect about a third of all of our brain synapses. So when we need to go to sleep, we're going to produce this neurotransmitter that's going to start blocking glutamate, which is called GABA, gamma-aminobutyric acid. Now, an example of this, there is a drug called Valium. Valium is an agonist to gamma-aminobutyric acid. So it's going to enhance gamma-aminobutyric acid's function as an inhibitory neurotransmitter. And so Valium is something that causes you to just want to lose consciousness. What it's doing is it's turning off glutamate by stimulating more gamma-aminobutyric acid. And when that occurs, the person's brain is going to be turned off. Valium turns your brain off, makes you want to go to sleep. And so this is just one example of how different neurotransmitters can be agonists or antagonists. So gamma-aminobutyric acid is an antagonist to glutamate. Valium, this medication, is an agonist to the gamma-aminobutyric acid. So it's going to turn your brain off. I always think, every time I think of Valium, I think of Spaceballs. If you've seen that movie Spaceballs, the princess is supposed to marry this prince named Prince Valium, and he's always falling asleep. And this is the reason why. So I just thought I'd share that with you. If you haven't seen that movie, you need to, watch Spaceballs. All right, so we'll move on into the next video.